Hey, good day everyone, and welcome to today's session. I waste a lot of time on the introduction today, so I think Tom has a lot to tell. So we can just go ahead. Today's topic will be about observability with the Elastic Stack and Lightrun. And I think Tom will guide us not only through the basics of theory, but also do all the practical sessions. So I'm looking forward on how to use Lightrun, and I would just say go ahead. If you have questions, just put them into the chat. I think Tom will be there and answer things. There's a colleague of Tom over there, so there are enough people to answer things. I will hopefully answer all the administrative things over there. And yeah, with that said, I would just say take it away, Tom, and go ahead.
So first of all, thank you very much, Alexander, for having me over here at the Elastic Meetup Series. And I'd like to, before I jump right into things, mention that Itai, an R&D team leader on our team, as Alexander mentioned, is on the chat. So feel free to ask away, even if I'm kind of midway talking, and Itai will pick it up. And in addition, thank you for the entire Elastic team that allowed me to be over here, which is Dalia, Alexander, David, and Philip, I think. So thank you for that. And can I just start sharing? Is that okay? Excellent. Let's do this. All right. So full cycle observability with Elastic and the Lightrun stack. First and foremost, I'd like to introduce myself. My name is Tom. I work for Lightrun. My details are right here in the slide. These slides will appear in the show notes right after the final event is being published in the description under the YouTube video. If you want to reach out to me regarding everything from setting up Lightrun through integrating with Elastic and everything in between, feel free to reach out either over Twitter, my DMs are open, or in my email, tomg@lightrun.com. And everything you can see here will be available, or actually it's already available, in the form of a blog post, which I will link to in a minute. And you can check it out if you prefer the short textual version instead of the full video version. So what are we going to do today? First and foremost, I want to share a quick word of history about where we started out, how this entire project came to be that resulted in this meetup. Then we're going to talk a little bit about observability, what it is, from a definition made by the vice president of product for observability at Elastic. Then we're going to talk about logging generally in the software world, why it is a difficult problem, why it requires proper thinking, proper planning, and proper work to get right. Then we'll talk tiny bit about Elastic Observability as a whole, and more specifically about what it is in comparison to the existing tools in the market. Show Lightrun, walk you through the architecture, what it does, how it works, what you can do with it, and finally go on with a full demonstration of the capabilities of both Elastic and Lightrun. Just a reminder, I can't actually see the comments while you're talking. That is for Itai to answer in the chat. Feel free to ping him there and he will pick up anything that comes up. In addition, while this session is about 25, 30 minutes, if I don't run over, we also have a section at the end there that is dedicated specifically for Q&A. So if you want to do some face-to-face time, we can do that as well right after the session ends. So I can actually answer you with my voice and not just over text. So let's go. As I mentioned, we started out this entire concept by a conversation we had with the Elastic team. We brought to their attention the existence of our integration, and we talked about how we can best showcase this amazing integrated capability into the world. And we started out by writing a blog post, which is available in the link right here. And in addition, we set up to do this live meetup that shows one specific feature of the Lightrun stack integrated directly into Elastic Observability. Lightrun has a bunch of other features which will roll out in, hopefully, future sessions and meetups with Elastic. And if you have more specific questions about features that I'm not showing in the video, but you might have seen on the website or in some of our other webinars or videos, again, feel free to reach out. My email and Twitter are right here on those slides. So observability, it's a big word. It's being thrown a lot around by many different types of vendors. It's also a thing that has been growing on R&D KPI lists. It is important to not just build a system that is robust, that is reliable. It is becoming more and more important to build a system that is observable, which means it is easy to do X with it. And the X is something that many people kind of have a different opinion on. So what I took here is a definition for observability, the general term, brought forth by Tanya Bragin, which is the VP product of Elastic Observability. And she pinpointed, I think, exactly the hardest thing to get about observability, which is the desired outcome. And I'll just read the definition for a second. Observability is not something that a vendor delivers in a box. It is an attribute of a system you build, much like usability, high availability, and stability. You aim for it. The goal of designing and building an observable system is to make sure that when it is run in production, operators responsible for it can detect undesirable behaviors, for example, service downtime, errors, slow responses, and so forth, and have, get this, actionable information to pin down root cause in an effective manner. Now, this is the key part here, have actionable information. This is also how Lightrun chimes in when the design of the code that you originally did, the logs you originally had when you wrote your application, are simply not enough, even with powerhouse tools like Elastic Observability. And we'll talk about this a bit later, but I wanted to frame what it is we're going to talk about today, this concept of observability and how we can be better at it. Now, as probably everyone here knows, logging is not that easy. As in, it appears to be this simple thing that you add a few log lines in your application, and then you can see them after in the aggregator or maybe even in the text file or whatever, and anywhere you consume your logs. Logging generally, preparing the system to be logged correctly, applying all the relevant frameworks, analyzing, consuming the information, storing it later, getting the actionable information out of it is a difficult problem. And I think the entire concept of this integration in the webinar, the meetup, sorry, that we are running right now, is around solving various types of problems inside, sub-problems inside this bigger problems. So I'd like to list a few of the considerations you might have when trying to build a system that is loggable or easy to log. And these are the difficulties around this topic. So first of all, logs generally are formatted inconsistently, as in not every system logs everything in the same way. So there's some parsing that needs to happen in the way. Elastic has beats, for example, file beat, metric beat, or have a bunch of different things that allow you to massage, quote unquote, information before it is being consumed on the other end. In addition, the information itself that is being logged out of the application is inconsistent. You log in a certain way, and then third-party library that you use logs in a different way. And this is not because you are messy or they are messy or you are wrong or they are wrong or anybody is incorrect. It's just the nature of the current ecosystem of software that we have. Many different hands wrote, many different lines of code, and many different lines of logs, and they need to be somehow combined and connected into a single graph, quote unquote, of understanding. In addition, practically speaking, log files are usually spread out across the host you're working on. So you have files that are stored in the application folder itself. You have logs that are stored in /var/log. You have logs that are stored sometimes in some external storage that is attached to the machine, block store drive or something of that sort. And furthermore, logs are actually spread out across multiple hosts today. Think about Kubernetes clusters. Think about just a group of machines working together to perform some sort of action. One log will be on one machine, one log will be another machine, sometimes inside a container, sometimes inside a virtual machine. It's a piece of it, all the relevant pieces of information are spread out in many different places. The next to last comment here is about the price of it all. And this is from the organizational perspective. Somebody has to foot the bill for logging and analyzing those logs later on. And if you want to have as much logs as possible in the lower amount of granularity possible, in the highest amount of granularity possible, the logs that are as granular and detailed as possible, they will be expensive to store over time. So we have a bunch of different things we do to solve that. Some people rotate out logs over time, basically write over all the logs or throw them out. Some people lower the level of granularity they log their application with. There's a bunch of solutions there, but this is not even the final straw. Even if you optimize on the storage level, you also have to optimize on the analysis level, because it's not always easy to run queries, expensive queries, machine time consuming queries that will give you the correct information. And it's not just writing the query, it's actually extracting information that is difficult, but actually the machine time, the resources used to analyze those logs, they are also quite expensive. Now, all of those are things that I don't think I'm saying something new to anyone here. These are kind of tenets of writing of building logging for a system. The thing that I want to focus on is the concept of unknown unknowns. And this is a tricky one, because even with the best logging system in the world and optimization of the storage cost and ensuring that consistency across logs are being complied with and automatic style checks and everything that you can think of along the way, there are sometimes things that you did not anticipate when you wrote the original log you wrote. And to give you an example, and we also see one of those later on in the demo, sometimes you create a system and expect it to be used in a certain way. And then perhaps an abuser or just a normal user use it in a different way. And the specific code path the users went down is not the one you expected them to. And that creates places where you have sort of black holes of logging, quote unquote, where either the logs are there but they're not significant enough because you have not thought to log for it properly, or you didn't know you need to log for it at all. There is a space you didn't think you would really need the logs there, or perhaps you increased or decreased the log levels in certain ways that change the way you can consume the logs later on. It is difficult to understand what is going on. And this topic of unknown unknowns is really tricky because you cannot plan for it. You need to build your system in advance to account for these unknown unknowns when they happen. Now, Elastic Observability, which is the system we're going to use today, is actually a single pane of glass, if you will, that combines a few different tools. This is taken from the Elastic material, and it talks about the various tools that you currently have in the observability world. If you want to build a system that is observable, you usually need one or all of those tools to figure out what is going on. So first of all, you have the development team with an APM tool. There's a bunch of them on the market, Elastic being one, obviously, that are consumed mostly by the development team. They contain traces and stuff of that form that enables you to understand how your application behaves like. In addition, you need an uptime tool that is usually used by the ops team to make sure that the services are actually up, that they are available when they need to be available, and then account for what happens when there are downtimes. But these are for more kind of advanced and more robust tools. In addition, you need a metrics tool, and the metrics tool is it's a very generic term for something that is can be as specific as the CPU usage on a specific machine, or even the amount of items in a specific queue somewhere in your system. These metrics tools are often attached to a visualization tool that enables you to graph various things in your system. And in addition, of course, you have the logging tool, which is just a logging analyzer and consumer. Sometimes there's also property in the way that transform those logs, like FileBit, for example, and sometimes not. In any case, Elastic Observability wants to take this entire suite of tools and attach them or combine them into a single pane of glass, single operational store. And I think the key factor of why Lightrun and Elastic Observability plays really nice together is that all data is just another index in Elasticsearch. And this is a really interesting topic. What Elastic Observability is saying basically is that we'd like to have the person consuming the information on the other side have the easiest way to understand, analyze, consume, and get actionable information out of the data coming in. And this is not a simple task because the data is inconsistently formatted, the collecting it is not an easy task, and just plain looking at the logs can be a big cognitive overload. It's difficult to understand what is going on inside any given system at any given time. It's not an easy problem. Now, to kind of step back for a second, if you will, from the general topic of observability, I want to talk about our tool, the tool my company builds, which is Lightrun, and explain how it fits into this entire narrative of things. And I want to, before I jump in, I want to mention that you already have a bunch of information inside your suite of tools inside Elastic Observability. You have an APM, you have an uptime data tool, you have a metrics tool, you have a log data tool. Lightrun comes in to fill a specific need that is relating not to the information you planned for, the information you already instrumented metrics for, added logs for, and so forth, but instead to information you did not anticipate you would need. And Lightrun basically, and I don't want to focus too much on the introduction, I want to jump right into the practicality and show you how things look like, is a clever set of tools for real-time observability. We currently support JVM, Node.js, Python, and other runtimes coming soon. And what the platform actually enables you to do is this. You have a set of actions, this is the internal name for them, that allow you to understand things that happen in production as they happen, in real time and on the fly. And the things you can add, these actions you can take, are logs, which is pretty much like a normal log line. You can add a log line where no log line was there before. We're going to see it in the demonstration in a second. Snapshots, which are virtual breakpoints, you can add them and get a sense of kind of like in a normal debugger, like you would see breakpoint by breakpoint and stuff like that, and to understand what a various set of frames look like, and then inside each frame, what happens inside that frame, which variables, objects, arrays, and so forth. You can see that same view, that breakpoint view, without stopping the running service. And you can also instrument metrics, which are things like how many times I've reached a certain log line, how much time a method took to run, how much time any arbitrary set of lines of code took to run, and so forth. We have great information about that on our website. I'll link to it. I actually linked to it a bit later in the presentation. And given all of those tools, all of these actions you can add to a machine, you can start answering these unknown unknowns I talked about before. It enables you to add information where no information was there before, in order to better understand your system in addition to the existing information. And I want to repeat this point because I might have been a bit unclear. The amount of information that is being logged in any given production system is immense. There's currently, in the way we work with logs, we try and think about all the different edge cases that we'd like to have for our application, basically all the things that can go wrong. We add logs, both procedural, basically things that show us where in the application we are, and a set of logs that help us with specific tough edge cases. What Lightrun does is enable you to enrich the existing log stream with more information that wasn't there when you originally added those logs before, which means you don't have to go through recompilation, redeployment, go through the entire CI/CD pipeline just to add another log. And using this Elastic integration we're going to see in a moment, you can also consume them right next to the application logs, which allows you for a constant, nice, real-time stream of everything that's happening in the system. One extra benefit of Lightrun is that we do not require any direct connection from a dev machine to a production machine. We have a different mechanism. I'll show a diagram in a moment that explains exactly what this is. It allows you, as I mentioned, to tackle unknown unknowns, and you can see everything in Elastic, which is nice and awesome. So the actual system, Lightrun, this is a very simple schematic of how it looks like. The client you can use for adding Lightrun information is either an IDE plugin. We support most JetBrains IDEs, and we also have support for Visual Studio Code coming out soon. Other IDEs next to the runtimes will also be released as we release more and more features in the future. A developer might look at the plugin, we'll see it in a moment, and add a new action to the system. What actually happens is that the developer is talking to a central server. This central server can actually run either on our end, i.e. in our own hosted version, or we can hand you a server to run on-prem for more air-gapped or closed-off systems. And then this management server has a connection to these agents running in a production system. And those agents basically query that management server at any given time, asking them, is there a new state that we need to instrument? And this is where the magic happens, basically. The agent, when a new action is being requested, for example, when a developer on the left-hand side is asking for a new log to be added to production machine A, the management server holds the state, asks, or rather holds the state and wait for the agent to ask for that information. The agent knows that there is new state to be instrumented and does the magic on the fly. Now, first and foremost, as most demos go, I want to show you as much as I can in the amount of time that I have left for this conversation. I do urge you, if you have things that we didn't end up showing in this demo, please feel free to reach out either to myself or over the comments, so Itai perhaps can direct you into relevant resources. We have a bunch of videos on our YouTube site as well. But this demonstration is a very specific one and deals with adding more logs where no logs were there before. And to talk about exactly what it is I'm going to show, I want to do a very, very quick introduction to Spring Pet Clinic. I guess most Java developers who have worked with Spring know this application. It is basically the most commonly used example application for Spring, which is a major Java framework. The actual application is quite complex. There's a bunch of things going on in it. This is a kind of a top-level view of it. There's a person who is looking at a system. That system is the Spring Pet Clinic system. It is a unsurprisingly, a pet clinic management system. It enables a person to perform various actions inside the pet clinic. For example, add an owner, remove an owner, do various things with pets, and visits for owners who come to visit the clinic with their pets, and so forth. And what we're going to show is a very specific use case in which we explore a certain piece of the code and try and add information where none was there before. Now, before I jump into the demo, let me just show you what the infrastructure actually looks like. So this is IntelliJ. IntelliJ is a very popular IDE. I don't have to tell you probably. Inside the left-hand side here, I know the font is a bit tiny. I try to increase the font inside the code editor. I hope that would be enough. But again, feel free to ask questions and follow up on any kind of what is not clear inside the demonstration with Itai in the comments. On the left-hand side, I have the tree for all the relevant things that happen inside the project. Specifically, I have opened the owner folder here, which has a bunch of controllers, the visit controller, the owner controller, and so forth, things that do stuff inside the application for the pet clinic management system. So I'll take a sip of my drink. And inside this application, which I will show you right now, there is a management screen. And to get there, to start working with the system, I'm going to run it. And you can see inside this is the same application that I have precompiled here. Inside the terminal here, you can see that I have a flag, an agent path flag, which is how you instrument Lightrun. I'm going to go back to that in a moment. Please disregard it for now and just consume this as, look at this in the same way you would run any type of Java application. In addition, in another terminal here, I have FileBit ready to run, and I'm going to run it as well. It is asking for my password. And you can see that FileBit has started running. Just a reminder, FileBit is, in this case, just running inside my terminal here and not as a separate service. It has a 3-tier mechanism. It receives inputs, for example, log lines. It does filtering, which applies filters, which is basically massaging of the data before it is shipped off to somewhere else. And then it has outputs that it ships somewhere else. In this case, I have a local, not a local, but I have an Elastic instance running, which I'll show in a minute. And this FileBit, the FileBit here is configured to ship information over to the remote instance. Specifically, if you look at the FileBit YAML file, you will note that I have configured two different types here, two different log sources here. So the first one is the Lightrun logs. I'll get back to that in a second, but the second one is the Spring Pet Clinic logs. This is just a simple, normal configuration for Spring with Elastic. You can see that I am taking the My Application log out of the folder for Spring Pet Clinic. It basically extracts the logs that are appearing here and then ships them over to Elastic. And we have a bunch of, again, massaging that is done for the data. All of these have to do with the way the JSON is being used in names inside the things that I'm shipping over to Elastic. It will be expanded into subfields as well. And there's a bunch of other properties here that are obviously documented in Elastic's documentation. Now, the interesting thing about these logs is that I can see a real-time stream of them right here in Elastic Observability. So I'm going to do a stream live of My Application logs. And you can see already right here inside the Elastic Observability log stream, you can see all of the logs that are being emitted from the Spring Pet Clinic application. Now, to anyone who has ever worked with Elastic, this is not news. This is a very simple use of Elastic. I configured Spring, a very popular framework, to dump all the logs over to Elastic. And I want to focus on perhaps a new use case for Elastic that would be once we integrate it with Lightrun. So I'd like to show you, this is the management screen of the application. And I want to go into the Find Owners screen. This Find Owner screen here has a bunch of features, basically two. You can search for an owner using their last name, or you can add a new owner. And the actual blog post has the full lay of the land. It shows the entire problem that we have instrumented for this specific use case. But the general notion is this. Over time, the code in the Spring Pet Clinic application might and probably will change. People will add features as the system matures. People will remove features as they become craft and irrelevant to the system. And specifically, we took the original Spring path clinic as it is provided by Spring. I think it was Pivotal originally. I guess it's VMware now, if I'm not mistaken. And we added a small bit to it. And if you look in IntelliJ here, inside the owner controller, we have added a property. We have added this variable here. Number of owners equals 10, which means we will start our controller, we'll start our application by assuming that the number of owners in the system is 10. Now, as every new owner is added to the system, number of owners, as every new owner is added to the system, by going to this method here, process creation from, which conforms to the owner's new API endpoint, we will increment the number of owners added to the system. Now, assume this is a feature that has been added later on in time. It is not something the original people who designed the system thought about because they forgot. And then eventually along the way, some people wanted to know what the number of owners in the given system is. But if you will kind of carefully look, and I don't know if anyone is already familiar with this application or not, but the original version of this application has no way of removing owners from the system, which is basically saying, yeah, we are a great pet clinic, no owner ever leaves. Why should we ever implement any type of removal mechanism, which is a very positive way of looking at the world, I assume. And this is basically where Lightrun fits in. We're looking at any type of problem that is not easily discernible just by looking at the logs of the application. And we would like to add more information in order to better observe it. Now, assume that that this method has been added, a way to remove various owners from the system. But for some reason, the person who added the route to remove the owners from the system did not decrement the number of owners as they did. Now, that would basically create a mismatch. The number of owners in the system will never match the actual amount of owners, because when you add an owner, you increment the number of owners property, you add more owners to the number of owners. But when you remove an owner, you don't decrement the count. You don't remove an owner from the number of owners count. And if you look at the application logs that are shown in Elastic, and I will go now, and this is an automated error that happens when you click the error button here. I'm going to now add a new owner. And I'm going to do, let's call it Tom, Granot, address, city, and add some phone number. If I add an owner, and I look at the logs now, there's no way of knowing that a new owner was added simply by looking at the logs, which means that currently I have no way to access this number of owners properly. It is a difficult piece of information to get out of the system. This is basically where Lightrun comes in. And I want to, before I jump into how we add this information into the running application, I want to jump back to the application and how I ran it in the beginning here. And I want to remind you of this little Java agent path flag that appears here. This is how you instrument Lightrun with a JVM. You add our binary, the shared object, like the Lightrun agent shared object, add it to the path, and then spin up the application as you normally would. What actually happens is that an agent is attaching, I'm highlighting the agent right here on the right, is attaching to your process, to the JVM process, and now enables you to add these real-time logs into the application. And to clarify, what you're looking at here is a normal IntelliJ. On the right-hand side and on the bottom, you will see the Lightrun console, and in addition, the Lightrun sidebar. These two are the main interfaces of the IntelliJ plugin for Lightrun, and they enable you to see all the running agents, in this case, the Elastic Lightrun demo agent, which is just the Spring Pet Clinic application we just created, and do actions with them, basically add more information to them. Now, remember, I am not directly connected to this agent. I am talking to a middleman, an intermediary server that holds the state, and the agent, in this case, running on my machine, but in practice, usually running in some remote production machine, will be connected to this management server, this remote management server, and ask for information from it, which means that I, as a developer, never connect to the remote machine. Now let's try and get this piece of information, this number of owners, from the production machine. What I'm going to do is I'm going to right-click and add a Lightrun log here. It asks me which agent I want to deploy the Lightrun log with, in this case, Elastic Lightrun demo, which file and line numbers I want to add it to, which is populated automatically because I am inside owner controller Java. And then what is the format of the log I want to add? Now, in this case, and there's a helpful pop-up here, I want to get the number of owners, and inside the actual log line, I want to add the value of the number of owners. So these curly brackets are just placeholders, kind of formatters, if you will, to add specific, basically any type of code level information you want into the log line. And in this case, what we're going to do is we're going to log the number of owners inside this very file. So I need to go and talk to the route, basically request the route. So this method, process creation form, will run, and this log line will be quote unquote invoked. I'm going to click OK, and I'm going to pipe this information right here using this button into the plugin and into the application itself. This is just a nice hack to allow you to show this log lines that you want, the log lines that you're seeing here, in the plugin itself and eventually in Elastic Observability. It is being emitted both to the std out of the application and into FileBit and then Elastic Observability by proxy. In addition, I also want to see this information right here in my IDE console. I'm going to switch back to my Spring application. I'm going to add another owner. Let's call it Tom II, which gives me a nice little title to my name, which is cool. Granot. Address. Second. And some random telephone number. Add owner. And now I have added a new owner into the application. And if you look here, you can see that the action has expired. I have run it once. This is a configurable mechanism. You can say how much time you want the action to actually be available for consumption. But on the bottom line here, you can see that there is the number of owners number has been emitted into the system, into the console. This is now a piece of information, number of owners, that wasn't available when I wrote the code itself, when I wrote the log lines in the code itself. And I have added that piece of information right into it is available right out of my IDE window on the fly, without actually stopping the service, without recompiling. This is not a hot swap on the bottom. It is basically a way to insert new logs into the stream where no logs have been added before. And to actually show you what it looks like in Elastic, you can see that now I have a new Elastic log inside the same stream of the application, same exact logs, with the new Lightrun logs here. And this concludes the actual demonstration that I wanted to show you. But before I leave you and we go over to the kind of the Q&A portion, because I'm already a bit over time, I want to mention one extra interesting thing about what just happened here. I talked earlier about, let me actually show my screen. I talked earlier about this concept of unknown unknowns, this line here. This is something that is not only hard to work around, it is not only difficult to understand that there is a problem where you are in the information that you're looking at. It is also hard to explain when you are trying to create an observable system. So just to kind of pinpoint something for the next time you're designing a system or thinking up of an architecture, when you're looking at the lines of code you write originally, when you're instrumenting the metrics that you want in order to better understand how the system performs, when you're looking at the traces and configuring your tracer and looking at everything that completes basically your application or makes it observable, basically when you configure all the relevant tools and build your application, always try and keep in mind that some things are just a factor of the system being changed over time, which is basically what happened here. We simulated a use case where a route was added later on without actually decrementing the specific property that we wanted to decrement. And that caused this gap in the knowledge of the application, which can be just normal, programmer error. But when designing your systems, try and put in mind all of those, or as much as possible, of those use cases as you can, because you can always create the system, you can build it in a way that enables you to answer those questions as fast as possible using tools like Elastic and Lightrun, but it requires a lot of thinking in advance. And I might not be renewing anything here, but this is something when we're designing a system that not everybody thinks about. We think about the data structures, the considerations for the storage cost on AWS, the way the queries will perform on the database. And we think about a lot of different problems. So when the next time you kind of list all the things you need when you're architecting a system, also consider the observability of it. Basically, how easy it would be to understand what is going on inside the application by simply looking at it and consuming the information. I think that concludes it for the actual kind of demonstration part of this talk, of this meetup, sorry. And I'd like to open the floor to anyone who might be interested in asking any kind of questions, comments, ideas, thoughts. I'm here, Itai is also here, and would be happy to answer.
Yeah, thanks a bunch, Tom, for talking. I think it's a super interesting technology demo, especially with the agent there in between. I haven't seen any question in the chat, but of course I do have one question.
Sure.
And that is, you're using this as an agent, and the Elastic Observability agent for the JVM is also one agent. Can you just run this with several agents? Because it's usually that nowadays, whenever you have any APM solution, be this Elastic or whatever else is out there, it's usually implemented as an agent within Java. And also, like, there are other solutions like security additions on top of the JVM, which are also working as an agent. So the main question is, like, can you just run all of these in parallel and you're still good to go and everything works as expected?
So I'll actually answer your questions in two parts, if you don't mind. So first of all, the question of actually prioritization of the agents inside the process itself. Yes, we can run with other APM agents, security agents. There's a bunch of them on the market now, and many companies use multiple. We can run alongside them as well, no problem. But there's actually a kind of a deeper consideration here if you think about it, because it's not only just a machine, in this case, the local JVM instance running on my machine that we usually work with. We usually work with multiple agents on multiple machines running multiple applications. And it can be a replica of the same service, so 5 containers running exactly the same piece of code, or it can be various different applications, multiple virtual machines running completely different workloads that we need to talk to. And I haven't shown this in this demo, but I would be very happy to catch up with anybody else who would like to talk about it, and hopefully we can go back to it in a further meetup down the road. Lightrun actually supports instrumentation of multiple agents at the same time. So what I can do is I can tag an agent. There's a mechanism you can change the configuration file, and for every replica of the same piece of code, you will be able to add a log line, like the number of owners run. Say there are 5 instances running this Spring Pet Cleaning application, and you will be able to see in real time every number of owners of every instance in the same log stream. So we will be able to instrument 5 logs at the same time with one button click and show them in the log stream of Elastic with the relevant tags of where the instance is from, AWS server 2, container number 7, whatever, and consume them in the same stream. And I think this is kind of the biggest problem, I think, in building software in the modern era, right? Everything's distributed. You're looking at things that are spread out everywhere. And the tools, and Elastic is a great example of that, need to conform to this new narrative. You need to conform to people building distributed systems and account for every type of need and problem they might have along the way. And much like Elastic, Lightrun also has different mechanisms to allow you for operating in a multi-instance environment, for example, tagging.
Yeah, that makes a ton of sense. I think one of the standard questions you probably get with every time you present this is the question of overhead for these kind of services. Like, how does this, or how is my production application affected by this, right?
Of course. Excellent question. So I haven't shown this, but there's a configuration file you can change, and that configuration file inside the agent folder controls a bunch of different things that all fall under the category of the Lightrun sandbox. The Lightrun sandbox is a mechanism that sits inside the agent and the server. It's a combined mechanism that enforces certain level of usage of machine resources by Lightrun. So for example, Lightrun, obviously, when it does the magic, quote unquote, when it adds the logs, there are some resources being consumed. To cap them, the Lightrun sandbox has a place in the configuration file. You can add a number that says how much of these resources can be used at any given time by Lightrun. So for example, Lightrun can only use 0.1% of the CPU resources available to the process at any given point in time, or I don't know, a few gigabytes of RAM, how much you like to allocate to it, how many logs can be emitted at any given point in time, and so forth and so forth. Lots of different configurations that are available. We obviously have a set of same defaults that we give out as part of the configuration. They, 99% of the time, work out, and we don't see any problem with them. And for users who have different kind of more niche workloads that have specific considerations, more IO bound, more CPU bound, depending on exactly, more memory bound, depending on how you construct your application, they can tune Lightrun accordingly at startup. And if I'm already talking about the Lightrun sandbox, one extra thing that I didn't mention here is keep in mind that you basically can add any type of Java expression there in a log. Now, Java expressions have side effects, right? Not all of them have completely read-only capabilities. What Lightrun does, and this is very important to mention, and we in more larger demonstrations, we actually show the sandbox itself. We have a way of looking at the expression that you added and ensuring that it has no side effects. And the Lightrun sandbox, aside from capping the resource usage of every kind of vertical you might be worried about, also protects you from changing state, from modifying your service when all you want to do was basically add a new logline and read more information. And I guess we'll jump into it in a further session, but I am open for more questions if anybody has any. Yeah.
Right. Yeah, thanks. I just took another look at the chat. There were no further questions. And yeah, unfortunately, I'm super interested in all the details, but I think we can definitely save that one for another session, so we can safely postpone that.
Mm-hmm.
Yeah, that's it. Do you have like any final word summary where you really like want to get rid?
Yes.
Is there maybe you want to share a URL or anything like that so people can take a look?
Yes. So first and foremost, I will ask. I'm not sure I can add comments here, Alexander. Do I need permission to? There's no way to add a comment.
You should be able to with a comments button in the right top corner, but I can do it for you if you just say.
Sure. So you can just go to https://lightrun.com. So basically just lightrun.com. And on the right-hand side, there's a create an account or a sign up button right there on the right-hand top. It will lead you to creating a new account. The new account will show you how to set up the IDE, the agent, and basically all the relevant considerations when spinning up Lightrun. I do want to mention that if you have any further kind of more in-depth configuration questions, we also have a chat available on the website. Somebody from the R&D team will hop on and answer any questions everyone might have. And on a final note, if you don't mind, something a bit personal. So I'm coming from the ops role. I was a site reliability engineer before I joined Lightrun and took on this more forward-facing role. And one of the key things and we worked with heavily distributed systems. And one of the core problems that I distinctly remember kind of having is explaining the requirement for crafting systems that are observable. And both Elastic and I'm proud to say Lightrun support this notion of building the systems correctly. If you build the system correctly and you build it as part of the considerations you put into the system design in an observable way, it matters. It saves you hours during the night. It saves you money in cloud costs. It saves your engineers frustration. It makes sense. So when you're designing systems, try and think about the person who needs to maintain them on the other end. Sometimes it's you if you're the product owner, but just place it under advisory. Think about it when you're building your systems. And thank you so much for being here and listening to me ramble on and on about observability. It's been a pleasure.
Yeah, great to have you. Like I thoroughly enjoyed this, and I can fully relate to running things in production and getting the pager off at night. Like when the first one who wakes up is usually not you, but your wife. So those are the challenges we all have faced, I guess.
Definitely.
All right, that's it. I would say thanks a ton again. We're going to call it a day. Like the last thing I can obviously give you as a link is the upcoming Elasticon conference, where we'll have basically a couple of days, depending on your time zone, full of talks and sessions all across the products, be it observability, be it our security solution, or another deep dive into the stack and new features in cloud. So make sure you're going to join. I think it's from the 5th to 7th of October. So make sure you have at least a day free in your calendar over there. And yeah, that's it. Thanks a lot, Tom. Thanks a lot to Itai for taking a look at the chat.
Thank you,
and
Itai.
See